Here we go, grade 9s. We're into outcome number 3 in chemistry. So once again, here's where you get the video notes and the explanations, and then in my Google Stream, that's when I tell you about which assignments you're doing. So topic 3, what are elements? So there's a group of people called the alchemists. They developed many useful procedures. These are the original chemistry people. They invented chemistry essentially. They made lots of useful procedures like distillation and described the properties of lots of different materials. Now, they were a secretive group. They had their own secret society. What were they originally trying to do? They were trying to change stuff like lead, which is very inexpensive, and find a way to try and change it into gold. What led them to think that they might be able to do this? Well, they saw that, you can mix chemicals together, they would react, and then new chemicals would show up. So their idea was that lead is pretty close to gold in its properties, probably just a little bit tweaking, we can change lead into gold. They had to make their own secret shorthand, because if they did figure out how to do this, they couldn't leave notes behind for everyone else to figure out how to do this as well. And so here's your classic picture of the alchemists. You can see lots of different urns, a distillation apparatus, and ways to mix things together. Did they succeed? They succeeded in getting the start of chemistry. Did they succeed in changing lead into gold? No. In order to change lead into gold, you have to do a nuclear change. You have to change the number of protons in the nucleus, and you can't really do that. Is it theoretically possible? I suppose, but from a financial point of view, it costs you way more money to do that than to actually get gold out of the ground. And so it's not feasible for us to do that. Plus, if they could do that, there'd be so much gold on the planet, and then gold would not be as valuable anymore. Anyways, the alchemists, all the chemists. Next person to come along in chemistry was Sir Francis Bacon, and you don't need to know the dates. It's nice to know some of the names. Sir Francis Bacon said science should be based on experimental evidence. Okay, and he died for his beliefs. There's something called Darwin Awards, where people have done things that are not so overly bright, and so like Darwinism, right? The evolution, and so these people would be excluded from the evolution and changing of people. He won one. Sir Francis Bacon was drinking some wine and eating some chicken one evening and came up with an idea. I wonder which one would freeze faster, a chicken shoved in a snowbank or a chicken stuffed with snow and shoved in a snowbank. And so he did the experiment, and they found him frozen to death the next morning, unfortunately. Sir Robert Boyle is the next person to come on, and he recognized that elements combine to form compounds. Once he announced that, the whole world went crazy trying to break compounds into their elements. In fact, not until electricity was invented were they able to really fully realize what they could do with his statement. Okay, and this was a race for discovering lots of different elements. Okay, and chemists then took chemicals, broke them down in another way. They tried to react them, they mixed them, they heated them, they froze them. The Lavoisier team, Mr. and Mrs. Lavoisier, discovered a lot of these as well. Sorry, I'm getting used to this. Dalton's atomic theory, there's a big star beside it. You are responsible for all parts of Dalton's atomic theory. So first part of the theory, all matter is made up of tiny particles called atoms. Well, that's easy, it's atomic theory. Atoms cannot be created, destroyed, or divided into smaller particles. That kind of goes along with the law of conservation mass that we talked about earlier, that mass doesn't change. Mass can't change because atoms cannot be created or destroyed. They simply rearrange. Atoms of the same element are identical in mass and size, and atoms of one element are different mass and size from atoms of other elements. And copper has its own size, and gold has its own size, and oxygen and hydrogen, they each have their own sizes. And then finally, compounds are created when atoms of different elements link together in a definite fixed proportion. So compounds are made of different elements combined, like H2O, two hydrogen atoms, one oxygen atom, combined together, bonded together. And then, there's a picture of Dalton. Classic chemist, has a really big forehead. Okay, and then an element is a pure substance made up of one type of atom with its own special properties and cannot be broken down into simpler substances. Copper, gold, oxygen, sulfur. You have your own periodic table, so you have a list of all the elements. And by the way, for any quiz or test, you would always be allowed to use that table, of course. A compound is a pure substance made of two or more elements chemically combined together, and they can be broken down into elements by chemical means or by using electricity. All right, so here are some compounds you can see. Cu, one copper atom, one sulfur, four oxygens. NaCl, one sodium, one chlorine. How do I know that it's a new element? Every time you hit a new capital, that's a new element. And then here's H2O. Okay, those are all compounds, pure substances made of two or more different elements chemically combined. And then we have a little bit of information about laws, theories, models, and observations. So a law describes and summarizes something. By the way, laws have to be mathematical as well. Theory is an imaginary way to explain why something happens, but it's got to have some proof. Like I can come up with a theory that the Earth is shaped like a triangle, but unless I have any proof, it's not really theory. It's just the meanderings of a crazy old man like me. Okay, but if there's experiments to support it, then they started investigating even further. And of course, why do we use models? Why have I been showing you models like this as we've gone through chemistry class? Well, I can't actually show you this in real life, but I could show you how it would behave, and I can do a 3D thing with you as well. Sorry, just fooling around. So that is like methane gas. That's what we think the model is like. 4 hydrogen atoms, 1 carbon. We have lots of support that they're kind of arranged at these angles. Okay, but models are very useful for me to show you things that are impossible to actually see otherwise. Do we always get it right? No. Basically, we go through the whole scientific process. We see observations. We come up with a hypothesis. We start making some experiments. Then we get new results. We revise our experiments. Sometimes we have to go back and we have to change our hypothesis. Eventually, we'll get to a point where we got a pretty good explanation for why something and how something is happening. We get a theory, and there's more and more experiments, and more time is on it. We keep revising the theory. Sometimes we find something out. Oh, got to throw the theory out. Sometimes we find something, and we say, oh, for now, we're going to say this is an exception to the rule. Then eventually, when it always works and it's mathematical, it becomes a law. It has to be mathematical in order for anything to become a law. So the theory of natural selection will always be a theory of natural selection. You can't actually throw mathematics. Well, I mean, there's some mathematics that goes with it, but for now, just a theory. But a good theory. Okay, so let's have a quick look at the history of the atomic model. Ooh, I feel like I've skipped a spot. Maybe some previous page. Oh, okay. So before we get to here, Dalton had a theory that atoms were like billiard balls, but he didn't know anything about their structure. So oxygen is heavier than hydrogen, so oxygen was a bigger billiard ball than hydrogen, and that was it. And then we start getting some new information. Okay, Thomson comes along and figures out the outside of this is negative, and so he describes it as like a positive mass with little, if you will, rays and electrons stuck into the outside. So he knew the outside was minus and the inside was plus. Rutherford says all the mass is in the center. He does this cool experiment where he fires electrons at an atom and it bounces off the nucleus, and therefore he proves, but most of them just went straight through. So he proved that atoms are mostly empty space and that they have a dense nucleus. And then this part, really important, okay? So we know protons are positively charged, okay, and they're big and they're in the nucleus. The electrons, E minus, are negatively charged. They're small, they're orbiting outside of the nucleus, so there's the nucleus, that would be positive. The electrons are going around the outside, they're negative. And then neutrons have no charge, so that's an N with a little 0, okay, and no charge. The particles are really big and they're in the nucleus. You have protons and neutrons in the nucleus, you got electrons orbiting around the outside. Bohr takes that model and goes one step further and says, you know what? The electrons, the protons and neutrons are in the nucleus, but the electrons kind of go in orbits like the planets orbit around the sun. Okay, and so that's Bohr's model. And the truth, The truth is the de Broglie model, or closer to the truth. This is actually a great model for explaining everything up until grade 12. Once you get past there, you realize that electrons don't actually sit in shells like that. They sit in clouds. So they have places where they like to hang out, S, P, and D clouds, which you'll learn about in grade 12. Mathematically, there's formulas that predict where electrons will be and how much energy they will have and what level they're at as well. Way too much for grade 9. Of course, the assignment that goes along with this is page 114, but not all the questions. Only numbers 4, 5, and 7 are good. And so that is the end of topic 3 notes, and that's probably enough information for this video.